let's take a look now at some actual logarithmic laws, some log laws. First, let's just remember that when you multiply two numbers where the bases are the same, that's really important, the bases have to be the same. If you're multiplying, then you can add the exponents. 4 plus 5, which would be 3 to the 9. And if you have the bases the same, again, really important, and you divide, well, then you can subtract 8 minus 5, which gets you 2 cubed. Now, these laws need to be inverted. So here, when we're timesing, we added. So now, when we add, we're going to times. Okay? Here, when we divided, we subtracted. So we're now going to do the inverse. If we subtract, we're going to have to divide. And the whole idea is that we're trying to get it into a single term. Right now I've got this, and you're trying to condense it. I mean, I guess this technically is a single term because they're not being added here. But the idea is you're trying to make it smaller. You're not trying to make it into one thing. And so in your attempt to make it one thing, you're going to have a log law. Here the attempt was to use the exponent law. Okay, so that's what our goal is. So we've already seen this a couple videos ago at the beginning, but one of the most practical uses of logarithms is that when you take the log, the exponent gets to come down in front and turn to a multiply. So it is really useful to remove a power. So say you had 5 squared, and it was in an equation. If you wanted to, you could take a logarithm of both sides, and if you did that, so you have log of 5 squared, and then whatever's on the other side, I don't know. But this allows this thing to become a 2 times log of 5. Now you can see here, I didn't put a base, because I'm not actually solving a question right now. I don't really care, so I just left it as base 10. I didn't bother with choosing a base. Now, you can do the same thing here. If this was part of an equation and you were solving something, which is how I usually do this, only when I solve things, 10 to the power of negative 2, well, that allows you to bring that negative 2 down and log of 10. Now, what's actually really interesting about this one, and I didn't plan this, is the number that's here is actually a 10. And 10, log base 10 of 10. You should know what this is. This says 10 to the what gets me 10. Well, the answer to that is 1. So this thing just becomes a 1. So this is actually negative 2 times 1, which is negative 2. I didn't plan that, but it's good to keep an eye out. Like here, this is a 10 as well. This says 10 to the what gets me 5. Well, I don't know what that is, which is why I didn't bother even looking. I maybe entered my thoughts, but I just immediately dismissed it. But this one, I thought, oh, 10, 10. Okay, that I can actually do. And same thing here. If we were solving a question, it allows us to bring down the exponent. So we can take that exponent, bring it down, and we have a log of 10. And again, this is a base 10. It's not written, but it is. And that cancels out. So really this just becomes an x. So that is the power rule. It allows us to take exponents and bring them down in front. What's actually really interesting is that it allows us to do the opposite. Say you had 5 log of 2. So that was your number. Well, you could bring this 5 out. It would be log of 2 to the power of 5. It becomes what was in front now becomes the exponent. And 2 to the power of 5 is, I think, 32. So which one's nicer? Well, it doesn't really matter. The 5 out front or the 32, they're both going to be the same thing. But I'm just saying that you are able to take numbers in front. If it's timesing, which it is, 5 times, you can actually throw that back up into the exponent. So you can go both ways. You can bring the exponent down, or you can bring the multiplying up. Now, here's what I was saying before. If you have 2 logarithms, you can add them. And if you have 2 logarithms that are added, you can join them to be a multiply. So here's log of 12. Well, log of 12, I don't know why you would ever do this other than we're just proving a point here, but you can write it as 3 times 4. And because it's 3 times 4, because you're multiplying, you actually could write this as log of 3 plus log of 4. So we've taken something that is a single term and we split it up into 2 terms. Don't know why we did it, but it just goes to show that's what the log law does. If you're adding 2 things, you can put them together and you can multiply them. Or you can take a multiply and you can split them up. So like this one right here, there's a bunch of things, and say for some reason you want to split them all up. It's like, okay, well, I can make that a log 3, plus I can do a log x, plus I can do a log of y. So you can put all of those separately and turn it to an addition, because there's a log law that says if you're adding 2 logarithms and the bases are the same, and the base is 10, the base is 10, then you can join them together and multiply. And the opposite's true too. If they're multiplying, you can split them up into 2 additions. And the opposite here, I guess it's not really the opposite, but the division rule. And so if you are dividing 2 things, you can separate them into subtraction. Or if you're subtracting 2 of them, you can join them as a division. So this thing right here could be written as log of 12 minus log of 5. Again, I don't know why you would ever split something up. Generally, we like to simplify things and put them back to 1, but it is an option. Here, we can do this. Log of -8 subtract log of x. So because they're dividing, we can separate them and we can subtract them. And lastly here, we've got this change of base rule, which we will hardly use, but it is useful when we don't have a calculator that has the base button. So I can rewrite this as log of the bigger number divided by log of the base. So in here, both bases are 10. You don't actually write it. We've changed it. This was a log base 4. We've changed the bases to both be 10. And then our base was 4 and the inside was 7. So we just did it like that. So that's called the change of base rule. And you can do that for anything. If you, especially because you can do this in your calculator. A calculator can do this really easily. Some calculators have trouble because they don't give you the option of putting a little 4 in there, the little subscript. So this would be log of 25 divided by log of 5. So that's the change of base rule. That's not to me as important. I hardly ever use this rule. I generally use log 2 and log 3 when I'm simplifying things, and you will have to use log law 1 to solve. One thing to maybe write off to the side somewhere, I don't know if there's really no room, so just completely unrelated, but it is, if you ever have this, that's 1. Log base a of a is 1. And you can do an example. We could have here 5 of 5. And what this asks is 5 to the what gets me 5? Well, the only way to get the number that you started with is if it was a power of 1. So 5 to the 1. So the answer to this thing would be 1. So whenever you have log 5, 5, you end up getting 1. Whenever you have log 7, 7, 1. Log 100, 100, 1. That's why we say log AA, it doesn't matter what the number is, you always get 1. So that's really important if you want to pause that to write that down. But up here, when we first did this, I was showing you how to find the inverse, and we did a solving kind of question to get the y alone, and we took the log of both sides, and I told you log 2, 2. So you don't know this at the time, but log 2, 2 is just 1. Because this says 2 to the what gets me 2, while 2 to the power of 1 does. So this just becomes a 1. So that's where that came into play. So this has all just been kind of an introduction, and logarithms, the most useful part is solving. But what we're going to do in the next few videos is simplifying. And what I mean by that, well, not really. Some of them are simplifying. We're going to use the log laws to combine. So we're going to put these things together, all without a calculator. And then we're going to have ones like here where they are put together and we're going to want to split them apart. And then after that, we're going to be doing a ton of solving. It's almost all solving. But the next few videos will be just on using these log laws.